All right, we're going to review for your conceptual unit 4 and 5 review. All right, number 1, it says the function f is an even function if f of negative x equals, and you know how to fill in these boxes, equals f of x. In other words, no signs change. The graph of such a function is symmetric with respect to the y-axis. Remember, if you have an even function, the y-axis has to cut the function exactly in half. This half has to be a mirror image of that half. All right, if f is an odd function, then f of negative x equals negative on the outside, which means all signs change. And if it's an odd function, we say it's symmetric with respect to the origin, because if I took this half and reflected it down, it would look like this, and then if I reflected it over, it would look like the other half. Okay, so we say it's symmetric with respect to the origin. All right, it says determine if the function is even, odd, or neither. Now, of course, on your QB exam, you won't have the graphing calculator to check it, but what you do is you find g of negative x, which means you change all of the x's to negative x's, and you see what's going to happen. An even number of negatives is going to turn that positive. An odd number of negatives is going to make that odd. So if I look back at the original, x to the 10th was positive, it's still positive, but x to the 7th was positive, and now it's negative. So this one did not change signs, and this one did. So some did, some didn't, which means the function is neither. If you look at a graph, it's close, but the y-axis does not cut it exactly in half. This side has this little whoop-de-whoop here that's not on this side, so it's not a mirror image. And which means the y-axis does not cut it in half, which means it is not even. Okay, using the given graph of the function, find whether the function is even, odd, or neither. Well, you can tell by looking. If I took this half of the graph and reflected it over y, you get this half back. You can also check because of the ordered pairs. If you have an even function, then the only thing that will change is the sign of x. So if you see here, 3, 1, if I change the sign of x to negative 3, 1 and check it, it's also on the graph. Same with this one. The same ordered pair, then the x has an opposite sign. Okay, it's on the graph also, so that makes it an even function. Okay, it says for number 5, the degree of the polynomial function negative 2x cubed times x minus 1 times x plus 5 is 5. You're saying, how's it 5? I only see a 3. The highest degree is 3. Yeah, but remember, to get the degree and the leading coefficient, you have to multiply all of the first terms. I mean, technically, we'd want this whole function. But if I'm just looking for degree and leading coefficient, I just need the first term. So if I take the first term of each factor, that's going to give me negative 2x to the 5th. That'll be my first term. I don't know what the rest of the terms are, and I don't care. This tells me that the degree of the polynomial is 5 and that the leading coefficient is negative 2. Okay, every real zero of a polynomial function appears as an x-intercept. Your zeros are your x-intercepts of the graph. Okay, it says if r is a zero of even multiplicity, then the graph touches the x-axis and turns around. If r is a zero of odd multiplicity, then it crosses. Okay, this one says determine if it's a polynomial function. It's a polynomial function as long as you don't have letters in the denominator, negative exponents, what else? I can't think of what else. But anyway, I don't have any letters in the denominator, so it is a polynomial, and the degree would be the highest one, which is 4. Okay, this one is not a polynomial because of, oh, that was the other reason, a radical. This doesn't look like a radical, but if I rewrote that, that'd be the cube root of x. And you can't have letters under radicals. And what that means is you can't have letters with exponents that are fractions. So this is not a polynomial. Okay, it says determine if this one is. No, it is not, because you have a letter in the denominator. Okay, use the leading coefficient test to determine the end behavior of the graph of the given polynomial function. Then use this end behavior to match the polynomial function with its graph. Okay, this is for my degree is 8, which is even, which means my tails are going to point the same direction. My leading coefficient is negative, and negative tells you, since it's even, that both tails are going to point down and wiggle in the middle. So I'm looking for a function that has both tails down, which the only one that does is that one. So it's got to be A. Okay, it says find the zeros for the polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. When it's factored like this, and you can tell it's factored because it has parentheses, it makes life easy. You set each factor that has an x in it equal to 0. -9 doesn't have an x in it, so setting it to 0 makes no sense. So it's a factor, but it's not a zero factor. So I take my next one, x plus 4 equals 0, and I take my x plus 8 squared equals 0, and I solve them. Plus 4, x equals 4, square root, x plus 8 equals 0, minus 8, x equals -8. Now this one has multiplicity 1, because there was only one of those factors. This one has multiplicity 2, because of the degree 2. So the zeros are 4 and -8. The multiplicity of 4 is 1. The multiplicity of -8 is 2. So it says, does the graph of f of x cross or touch the x-axis and turn around at 4? Well, since 4 has an odd multiplicity, it's going to cross. And it says, does the graph of f of x cross or touch the x-axis and turn around at the x-intercept -8? Because it has an even multiplicity, that means it's going to touch and turn. And you can tell, again, you won't have this on your QB, but you can tell it crosses through at 4 and it touches and turns at -8. Okay, find the zeros for the given polynomial function, give the multiplicities, state whether it touches and turns or crosses. Okay, when this one isn't factored, it's a little harder. Okay, so when it's not factored, oh, look, I could factor it myself. It's a third degree, but they all have x's in it. So I'm going to try and factor out an x, which would leave x squared minus 6x plus 9. Now I can factor the second degree. Keep the x. This should be an easy factor. Since a is 1, x times x is x squared. Factors of 9 that make 6 would be 3 and 3. Since c is positive, they both get the middle, which is negative. So there's my function in factored form. So now I set each factor to 0 and solve. That's x equals 0 with a multiplicity of 1. This is x equals 3. This is x equals 3. So at x equals 3, it's multiplicity 2. Okay, so it says the zeros are 0 and 3. The multiplicity of the leftmost 0. Leftmost would be the 0. So it has multiplicity 1. The rightest, this 3 over here, it has multiplicity 2. And since at the leftmost it's an odd multiplicity, it will cross. And at the rightest one, if that's a word, the multiplicity is even, so it will touch and turn. Alright, so again, same directions. Okay, now this one, yeah, I can factor. I can factor myself. There's 4 terms, so 2 by 2. If I couldn't factor this myself, guys, that's when we would have to make the PQ list and test. But let's see if this works. 2 by 2. I can factor out an x squared, which would leave x plus 9. I can factor out a -9, which leaves x plus 9. So I can factor out an x plus 9, which leaves x squared minus 9 equals 0. So if I set these to 0 and solve, x plus 9 equals 0, x squared minus 9 equals 0, minus 9, x equals negative 9, plus 9, x squared equals 9, square root, x equals plus or minus 3. So my zeros are negative 9, positive 3, and negative 3. What order you list them in doesn't matter. The multiplicity of the greatest 0 is 1. That would be the greatest 0, and there's only one of them. The multiplicity of the second greatest, which would be negative 3, is 1, and the multiplicity of the smallest would be negative 9, is 1. Since they all have multiplicities 1, which are all odd, that means that at each one it will cross. And if you look, there's my negative 9, there's my negative 3, and there's my positive 3. Okay? Alright, it says find the zeros, state the multiplicity, write an equation expressed as the product of factors of a polynomial function for the graph, use a leading coefficient of 1 or negative 1, and make the degree of f as small as possible. C, use both the equation in part B and the graph to find the y-intercept. Alright, so we know that it crosses at negative 1, at 1, and at 2. So I know that x equals negative 1, and since it crosses through and I want to keep the degree as small as possible, it's got the smallest odd multiplicity, which is 1. This also tells me that x equals 1 with a multiplicity odd because it passes through, and since I want to keep the degree as small as possible, the smallest odd number is 1. Now at 2, that's got to have an even multiplicity. The smallest even number is 2, and the reason I know it has an even multiplicity is because it touches and turns. So it says, for A, find the zeros and state the multiplicity of each 0. It says that list the zeros whose multiplicity is even. So the only one that has an even multiplicity is 2. Then list the zeros whose multiplicity is odd. That would be these two, negative 1 and positive 1. Okay, so now to write an equation expressed as the product of factors, so we don't have to multiply them out. Why are they doing to the third? Oh, okay. Sorry. I'm sorry. Remember that little fact that says that, see how this one flattens out when it passes through where this one doesn't? It just kind of goes right through, and this one flattens out. That means that it has to have a multiplicity bigger than 1. So if it's got to have a multiplicity bigger than 1, but I want to keep the degree as small as possible, the next smallest odd number would be 3. That's where they're getting that 3 from. Oh, I almost messed up there. Okay, so my function then will be, if you write this as a factor, okay, we got x equals negative 1. To make it a factor again, add 1, x plus 1 equals 0. So that factor is going to be to the third, okay? This factor, x equals 1, or that 0, make it a factor, minus 1, x minus 1 equals 0. That's going to have a multiplicity of 1, so x minus 1 to the first. And then my last one, x equals 2, minus 2, x minus 2 equals 0, is going to have a multiplicity of 2. Okay, so that's where they got their equation from. And then the y-intercept, algebraically, you could find f of 0. 0 plus 1 cubed, 0 minus 1, 0 minus 2 squared. This would be 1 cubed, this would be negative 1, this would be negative 2 squared. This would be 1 times negative 1 times positive 4, which would be negative 4. And you can also tell from the graph, it crosses right there at negative 4. Okay? Alright, it says divide using long division, state the quotient q of x and the remainder r of x. Alright, so if we're going to do long division, 5x minus 3 is on the outside. Inside we have 15x squared plus 16x minus 7. We're going to go to the alley, and just the gang leader and the lead detective go to the alley. So we have 15x squared divided by 5x, which would leave 3x. So that goes up and multiplies down. 3x times 5x is 15x squared. 3x times negative 3 is negative 9x. But I'm going to draw the line and change both signs, and the square cancels. Add those and I get 25x minus 7. So now I'm going to go back to the alley. New gang leader. And we're going to do 25x divided by 5x would leave positive 5. Goes up and multiplies down. 5 times 5x is 25x. 5 times negative 3 is negative 15. But when I draw the line, I change both signs and the first degree cancels. Do the math and I get positive 8 for remainder. So there's your quotient. And there's your remainder. Okay? Alright. This one they want synthetic division. When you do synthetic division, you put positive 1. You don't put the factor. That's a factor. You put the 0 in the hole. So plus 1, x equals 1. So I put 1 in the hole. I have my 5th degree coefficient, my 4th, my 3rd. No, my 4th, I have a 3rd. My 3rd degree is a positive 7. My 2nd degree, my 1st degree, and my constant. Don't forget those placeholders, or it will never come out right. Okay, so 1 comes out, multiplies by 1, brings back 1. 0 eats 1. Comes out 1. Goes back and multiplies by 1, brings back 1. 7 eats 1. Comes out 8. Times 1 is 8. 0 plus 8 is 8. Times 1 is 8. 0 plus 8 is 8. Times 1 is 8. Negative 8 plus 8 is remainder 0. Okay, so now we had a 5th degree starting out, which means my quotient is 1 degree less. So since I was dividing into a 5th degree, my first term is a 4th degree, then my 3rd degree, then my 2nd degree, then my 1st degree, then my constant. So there's my quotient, x to the 4th plus x cubed plus 8x squared plus 8x plus 8 plus my remainder over my divisor. Okay? Alright, it says use synthetic division, use the result to find all zeros. So remember, my degree tells me that I've got to come up with 3 answers. So they're telling me to divide, and we can do synthetic. So I put negative 3 in the hole. And my 3rd degree coefficient, my 2nd degree coefficient, my 1st degree, and my constant. 1 comes out. Times negative 3 brings back negative 3. 7 minus 3 is positive 4. Times negative 3 is negative 12. Negative 9 minus 12 is negative 21. Times negative 3 is positive 63, which gives me a remainder of 0, which drops this down to a 2nd degree. So there's where they got their quotient. Okay, and then it says find the rest of the zeros. Well, I have 1. I have x equals negative 3. I know I have to come up with 2 other ones that I can now get out of this equation, because now it's a 2nd degree, and it should be an easy factor. X times x is x squared. Factors of 21 that make 4 would be 3 and 7. Since c is negative, only the bully gets the plus, and 3 doesn't. Set them to 0. Solve. Add 3, x equals 3, minus 7, x equals negative 7. There's my other 2 solutions. There's all three. All right. Use the table to determine the solution of the equation. Use synthetic division to verify that this number is a solution of the equation. Then solve the polynomial equation. Anytime you're looking for a solution, you're looking for an x-intercept. And you get x-intercepts when y is 0. So I'm looking for 0 in the y column, which is right there, which means that x equals 2 is a solution. Okay, so which solution can be determined from the table? 2. What are the other solutions? Well, I don't know. We're going to divide by the one we got. I can't factor that. Okay, and I can't solve it until I get it down to a second degree. So if I put 2 in the whole, my third degree coefficient, my second degree coefficient, my first degree coefficient, and my constant. Okay, 56 comes out. Times 2 is 112. Subtract, that's 5, that's 1. 2 times 15 is 30. Oh, that's negative. Yeah, so that'd be negative 30, which comes out positive 1, which comes back 2, which gives me a remainder of 0, which makes this depressed down to a second degree. So now I have to solve this. Okay? 56 times 1 is 56. Factors of 56 that make 15. Yeah, I don't know. I don't want to factor this one. Let's do quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let me get my calculator here. We're going to have x equals 15 plus or minus the square root of negative 15 squared minus 4 times 56 times 1. Oops. Hold on. My little fingers messed up. Negative 15 squared minus 4 times 56 times 1 is 1. Well then, that was simple. All over 112. So now I have 15 plus or minus 1 over 112. 15 plus 1 would be 16 over 112. 15 minus 1 would be 14 over 112. And if I math and or enter that, or use my brain, that would be, why aren't I getting the right answers? That is not 1/8 or 1/7. That's 14 divided by 112. Well, there's my 1/8. I don't know why that one's not. Oh, because I typed it wrong. 16 divided by 112, not 122. There's your 1/7. Okay, so there's my other two solutions. Careful when you're typing. Alright, says solutions of a squared equation that are not solutions of the original equation, those are your extraneous. Remember when we type them back and we plug them back in and they don't work, we have to throw them out. Alright, it says solve the polynomial equation by factoring and then using the zero product principle. If they want me to factor, then it's got to be factorable, but I got to get everything on the same side. So I'm going to minus 25x, which gets rid of that, and I'm going to minus 25, which gets rid of that, which gives me x cubed plus x squared minus 25x minus 25 equals 0. Since there's 4 terms, I'm going to try my 2 by 2 technique. I can factor out an x squared, which would leave x plus 1. I can factor out a negative 25, which would leave x plus 1. I can factor out an x plus 1, which leaves x squared minus 25. Set them to 0. minus 1, x equals -1, add 25, x squared equals 25, square root, x equals plus or minus 5. So my solutions are a -1, a +5, and a -5. Okay? Alright, it says find all real and complex roots. Remember, this is not quadratic, but it acts like a quadratic because this is half of that. If the middle is half of the first one, then it's still factorable. It's just that, and it should be an easy one because a is 1. It's just that instead of x being here, it's going to be x squared and x squared to get x to the 4th when you multiply it back together. Now I need factors of 32 that are going to make 18, which would be 2 and 16. We'll make 18, yeah? And since c is positive, they both get the negative. So I have x squared minus 2 equals 0 and x squared minus 16 equals 0. If I solve these, add 2, x squared equals 2, square root, x equals plus or minus, I can't break it down, so I leave it, plus or minus the square root of 2. And then if I solve this one, add 16, x squared equals 16, square root, x equals plus or minus 4. I needed 4 answers, I got 4 answers. Okay. Alright, using a graphing utility and the graph's x-intercepts to solve the equation. Okay, I could try and factor, but they're actually asking me to use a graphing utility. So I type it in my graphing calculator, and it's crossing at 0 and at 2. Or not crossing, but it's touching and turning. Okay. I wonder if I could factor that. Probably. Alright, it says if a plus bi is a root of a polynomial equation with real coefficients, b not equal to 0, then a minus bi is also a root. This was your complex conjugate theorem. Anytime you have an a plus bi, its conjugate is automatically another one. Alright, it says the following function is given. List all rational zeros that are possible according to the rational zero theorem. Choose the correct answer below. So if I take all the factors, my p has to be a factor of 45, which is 1, 45, 2, no, 3 and 15, 4, no, 5 and 9, 6, no, 7, no, 8, no, 9 and 5. I got them all. My q has to come from factors of 7, which are 1 and 7. So I have, taking my first one, 1 over 1, 1 over 7. Then my next one, I have 45 over 1, 45 over 7. And my next one, I have 3 over 1, 3 over 7. Next, 15 over 1, 15 over 7. 5 over 1, 5 over 7. 9 over 1, 9 over 7. Now, they clean them up a little bit. This will be plus or minus 1. This is plus or minus 1/7. This is plus or minus 45. This is plus or minus 45 over 7. This is plus or minus 3. This is plus or minus 3/7. This is plus or minus 15. This is plus or minus 15 over 7. This is plus or minus 5. This is plus or minus 5/7. This is plus or minus 9. And this is plus or minus 9/7. And again, what order you go in does not matter. Now, what we would do is, it says use synthetic division to test several possible rational zeros in order to identify one actual zero. And remember, we cheated. We found the list, and then we're going to use the graph. Now, they came up with this rational one, 5/7. I would have picked an easier one. It looks like it's crossing at 3 and at -3, and I'm not sure that's the 5/7, obviously. Again, they don't know that we're using the graph. I would pick one of these, Okay, and then I would use the 0 to find them all. So if I just divide by one of them, let's divide by the 3. Third degree, second degree, first degree, constant. 7 comes out. Times 3 is 21. I'll mess up. That is 16. Times 3 is 18. That's negative 45. Wait a minute, what happened? Oh, 6, not 6 times 3. 16 times 3 is 48. Negative 63 plus 48 is negative 15 times 3 is negative 45, which gives me my remainder 0. I knew I had to get 0 for remainder because it's a 0 on my graph's lying to me. So now we've dropped this down to a second degree. Okay, and we could try and factor it, or I would do quadratic formula because I don't want to do 7 times 15. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to give me negative 16 plus or minus the square root of 16 squared minus 4 times 7 times negative 15 is 676 all over 14. The square root of 676 is 26, so I have x equals negative 16 plus or minus 26 all over 14. So then I have negative 16 plus 26, which is 10 over 14. And I have negative 16 minus 26, which is negative 42 over 14. Simplify these, and this comes down to 5 over 7, and this comes out to negative 3. So I have the positive 3 I found from the list and the graph, and then I have 5/7 and negative 3 from breaking down the second degree after we divided and depressed it. Alright, answer the following questions about the equation below. List all the rationals. Your p has to come from factors of 6, which are 1, 6, 2, 3. Your q has to be a factor of 1, which is 1, which makes my life easy. Anything over 1 is just those with pluses or minuses. It says test several, but again, we're going to use the picture. And I can tell, I'm not really sure about that one, I'm not really sure about that one, but for sure 1, 2, 3, 4, it looks like it's crossing at 6. So if I take 6 and divide my third degree coefficient, my second degree, my first degree, my constant, 1 comes out, times 6 is 6, 0 plus 6 is 6, times 6 is 36. Negative 1 times 6 is negative 6, remainder 0, which it better be, or I did something wrong. Okay, and that depresses it down to a second degree function, which I can now do. I could try and factor, but the only factors of 1 are 1 that won't make 6, so it's not factorable, which means I've got to do quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That gives me negative 6 plus or minus the square root of, that's 36 plus 4 is 40, all over 2. If I break down 40, by 2 is 20, by 2 is 10, by 2 is 5. That saves a perfect square 2, and these two have to go back in. So now I have negative 6 plus or minus 2 square roots of 10 all over 2. And now I can reduce by 2, which gives me negative 3 plus or minus the square root of 10. So 6 I got from the graph, and those 2 I got from quadratic formula. Okay? Alright, find an nth degree polynomial function with real coefficients satisfying the given conditions. If you're using graphing utility, use it to graph the function, verify the real zeros of the given and the given function value. So they want a fourth degree, which means they've got to give me 4 answers. And they gave me x equals -1, there's 1. X equals 5. X equals 4 plus 4i. Wait, they only gave me 3 and I need 4. Well, that's because the complex conjugate theorem, they gave me an a plus bi, which means a minus bi is also a 0. Now, remember, so that's why they gave me this, and then they gave me this because I need to find that leading coefficient. My function is going to be not those zeros multiplied together, but those factors, which means I got to get everything on the same side. So add 1, that gives me x plus 1, minus 5, x minus 5, minus 4 gets rid of that, minus 4i gets rid of that, which gives me x minus 4 minus 4i equals 0. Minus 4 gets rid of that, add 4i gets rid of that, and that's x minus 4 plus 4i equals 0. So my function is f of x equals some leading coefficient times x plus 1 times x minus 5 times x minus 4 minus 4i times x minus 4 plus 4i. And that will be my function, other than finding this leading coefficient, which is why they gave me that information. But before I find my leading coefficient, I'm going to go ahead and multiply this out as much as I can. And I can multiply in any order I want. So right now I'm going to drop this, and I'm going to do this. That's x squared minus 5x plus x minus 5. And I'm going to do this one. X times x is x squared. X times -4, -4x. X times 4i is positive 4xi. -4 times x is -4x. -4 times -4 is positive 16. -4 times positive 4i is negative 16i. -4i times x is negative 4xi. -4i times -4 is positive 16i. And -4i times positive 4i is negative 16i squared. Okay, so now let's clean up all of these parentheses we got going on here. That's going to give me f of x equals a times x squared minus 4x minus 5, combine like terms. This big set, anything with an I in it is going to cancel. That positive 4xi, the negative 4xi, the positive 16i, the negative 16i. That turns into negative 16 times -1, which turns into positive 16 that I can combine with that one. The x's cancel, and I get x squared minus 8x plus 32. And I'm not going to FOIL that out. Well, I'm going to have to. But I'm going to get my leading coefficient first. And it doesn't matter when you find your leading coefficient. Alright, to find my leading coefficient, again, remember, I'm trying to solve for a, which means I've got to know every other letter. And I do. They gave me an x. This ordered pair would be 1, -200. So they're giving me an x of 1 and a y of -200. So this is f of x is like y. So I'm going to change that to -200 equals, I don't know, times 1 squared minus 4 times 1 minus 5. 1 squared minus 8 times 1 plus 32. And if I solve this, I have -200 equals a times, this is going to be 1 minus 4 minus 5. That's going to be -3 minus 5 is -8. This is going to be 1 minus 8 plus 32, which is 25. 25 times -8 is -200. Equals a times -200. So when I divide by -200, which I can't write because I'm sorry, let's go over here. So I got negative 200 equals a times negative 200. Divide by negative 200, and I get a equals 1. So we did all that mess just to figure out that a was 1. So now my function is, f of x equals 1 times x squared minus 4x minus 5 times x squared minus 8x plus 32. So now to get my polynomial, I'm going to multiply my leading coefficient, which multiplying by 1 doesn't do anything. So now I'm going to multiply these two. So x squared times x squared is x to the 4th. X squared times negative 8x is negative 8x cubed. X squared times 32 is 32x squared. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 8x is positive 32x squared. Negative 4x times 32 is, what was that, negative? Negative 128x. And last but not least, negative 5 times x squared is negative 5x squared. Negative 5 times negative 8x is positive 40x. And negative 5 times positive 32 is negative 160. So now if I combine like terms, my function is x to the 4th. Oops. My cubes, negative 8x cubed, negative 4x cubed is negative 12x cubed. My squares, negative 32x, positive 32x squared, positive 32x squared, negative 5x squared. So 32 plus 32 minus 5 is 59x squared. My linears, I got negative 128x and positive 40, which is negative 88x. And then bring down my constant, negative 160. There's your function. And then if you type it in and use those windows, you get the graph that matches it as that. Okay? Alright, it says use a graphing utility to obtain a complete graph for the polynomial function that determine the number of real zeros and the number of imaginary zeros. Okay, so you type this in the graphing calculator and you use your window so that you get the picture to match right. So it's that picture. Now, I've got to have 4 zeros all together. The real ones are the actual x-intercepts. And then whatever is left over has to be the imaginary ones. So I can plainly see that this thing only crosses the x-axis twice, which means there are 2 real zeros. And since there's got to be a total of 4, that means there are 2 imaginaries. Okay, an equation in which the variable occurs in a square root, cube root, or a higher root is called a radical equation. Find the real solutions of the equation. You got to isolate the square root or whatever root they're doing and kill it. So in this case, my radical is alone. So I'm ready to kill it by squaring it, but I got to do it to both sides. The square kills the square root, which leaves 35 minus 2x equals x squared. It's quadratic, so to solve it I need to get 0 on one side. So I don't want a squared term negative, so I'm going to move these two over. So minus 35, add 2x, I get 0 equals x squared plus 2x minus 35. Okay, and if I solve that now, it should be an easy factor. A is 1. So x times x is x squared. Factors of 35 that make 2 would be 5 and 7. Since c is negative, only the bully gets the plus and 5 won't. Set them to 0. Add 5, x equals 5, minus 7, x equals negative 7. Those are my 2 answers, so why did they only give me 1? Remember, anytime you have radicals, you have to check your solutions for extraneous ones. If I plug in 5, I get the square root of 35 minus 2 times 5 equals 5. That would be 10. 35 minus 10 is 25. Square root of 25 is 5. 5 equals 5. I can keep it. Plug in 7. 35 minus 2 times 7 equals 7. That's 35 minus 14 is the square root of 21, which does not equal 7, so I have to throw it. Oh crap, that was a negative 7. Oops. I'm still going to have to throw it out, but hold on, I plugged in the wrong number. Negative 7, so that'd be 35 plus 14, which is 49. Oh, wait a minute, that does work. Minus 2 times negative 7 will be positive 14. 7 equals 7. Huh. Minus 10 is 25. Square root of 25 is 5. 35 plus 14. Oh, I didn't plug in negative 7 on this side. And 7 does not equal negative 7. There you go. So we have to throw it out. Careful. Alright, solve this radical equation. To solve this one, I have to isolate the radical first. So I'm going to have to subtract this x, which gives me a negative square root of 4x minus 11 equals negative x plus 4. Divide by my negative, which gives me the square root of 4x minus 11 equals positive x minus 4. I've isolated, now I can kill it by squaring. That kills that, gives me 4x minus 11 equals 2 copies of x minus 4 so that you don't kill puppies. And simplify. 4x minus 11 equals x squared minus 4x plus 16. 4x minus 11 equals x squared minus 8x plus 16. And then I got to get everything on the same side, so I'm going to minus 4x and add 11. And that gives me 0 equals x squared minus 12x plus 27. And if I factor that, x times x is x squared. Factors of 27, 9, and 3 that make 12. Since c is positive, they both get the middle negative, which gives me x equals 9 and x equals 3. I skipped some steps there. I set them to 0 and got x alone by myself in my head. So now I have to check it. Let's check 9 minus the square root of 4 times 9 minus 11 and see if it equals 4. 9 minus, that's 36, minus 11 is 25. That's 9 minus 5, which is 4. 4 equals 4, I can keep it. Plug in the 3 and have 3 equals the square root of 4 times 3 minus 11 equals 4. 3 minus, not equals. That'd be 3 minus, 12 minus 11 is 1. That'd be 3 minus 1, which is 2, which does not equal 4, so we have to throw it out. Okay? Alright, and when we do this one, we've got to get one of these radicals alone. So I'm going to add the square root of x minus 9, which would give me the square root of x plus 24 equals 3 plus the square root of x minus 9. I've isolated 1 so I can kill it by squaring both sides, which gives me x plus 24 equals 2 copies multiplied together so I don't kill puppies. So I'm going to have x plus 24 3 times 3 is 9. 3 times that square root is 3 times that square root. Square root times 3 is 3 times that square root. Square root times the square root of it's the same thing. I mean, that's basically the square root of x minus 9 squared. Something times itself is squared, yes? So if I clean this mess up, I'm going to have x plus 24 equals 9 plus 6 square roots of x minus 9 plus x minus 9. So now, what I want to do is I want to start all over again and isolate this radical. So everything else has to go. Well, 9 minus 9 cancels each other out. So I need to move these two to the other side. So I'm going to minus x. Gets rid of that. Hey, Merry Christmas to me. So now I have 24 equals 6 square roots of x minus 9. To solve this, to isolate, I'm going to divide by 6. And I get 4 equals the square root of x minus 9. I've isolated that radical again, so now I can square both sides to kill it. And I get 16 equals x minus 9. Add 9, I get 25 equals x. And if I check it, I have the square root of 25 plus 24 minus the square root of 25 minus 9 equals 3. Well, that would be 49, which is 7. That's 16, right, which is 4. 7 minus 4 is 3. 3 equals 3. I can keep my answer. Alright? Solve and check the given equation with rational exponents. So I have x to the 3/2 equals 8. It's isolated, so I can kill these by raising to the reciprocal, which kills that and gets my x alone, and my answer is 8 to the 2/3. But I gotta simplify that. So we're going to put it back in radical form, which would be the cube root of 8 squared, which would be the cube root of 64. And if I break down 64, by 2 is 32, by 2 is 16, by 2 is 8, by 2 is 4, by 2 is 2. Perfect 2, perfect 2, perfect 2. Right? Oh, whoa. Sorry, we're not doing square roots, we're doing cube roots. So it takes 3. There's a perfect 2, and there's a perfect 2, and 2 times 2 is 4. Alright, this one, same thing, but we're going to have to isolate to kill, so I'm going to add 10. That gives me 5x to the 3/2 equals 10. Still not isolated, I got to get rid of that multiplier there, so divide by 5. I get x to the 3/2 equals 2. So now I can kill by raising to the reciprocal. Kills it. X is alone. And they said type an exact answer in simplified form. They left it 2 to the 2/3. And the reason is, I mean, if I tried to simplify that, that'd be the cube root of 2 squared, which would be the cube root of 4. And if I break down 4, there's not 3 of anything, so it can't be simplified. Alright, solve the equation with rational exponents. Again, I need to isolate this trinomial being raised to that, so I'm going to add 2. And that gives me x squared minus x minus 4 equals 8 to the 3/4, sorry. So now to kill that, I'm going to raise it to the 4/3, both sides, and I get x squared minus x minus 4 equals the cube root of 8 to the 4th. You could do 8 to the 4th, which is 4,096, and you can break it down. Or you could say, well, 3 goes into 4 one time, take away 3 leaves remainder 1, and this says that 1/8 is out and 1/8 is in. So this becomes 8 cube roots of 8, but the cube root of 8 is 2, so that becomes 8 times 2, which makes it 16. And if you wrote down the 4096 and broke it down, you'd get the same thing. So now it's quadratic. I've got to get 0 on one side. Minus 16 minus 16, that gives me x squared minus x minus 20 equals 0. This should be an easy factor. X times x is x squared. Factors of 20 that make 1 would be 4 and 5. Since c is negative, only the bully gets the middle, 4 doesn't. Solve it, which gives me x equals negative 4 and x equals 5. Alright, suppose that the graph of a function g is known. The graph of y equals g of x plus 2 may be obtained by a vertical shift, because it's outside, of the graph of g up a distance of 2 units. That 2 out there is going to shift it up twice. Okay, and if they've got this minus 2 on the inside, its inside is horizontal, and this would suggest left, but it's going to make it go right because it's with your crazy x. Okay, and it says decide whether the following statement is true or false. The graph of y equals, when the negative's on the outside, it reflects over x. When it's on the inside, it reflects over y. So that's a true statement. Okay, the graph of this, whatever the function is, they're multiplying by 6. It's outside, which means it's vertical, and it's going to be a stretch. And since it's outside, we multiply each of the y coordinates by 6. Because it's outside, you do it to y. Inside, you do it to x. Okay, whether it's true or false, it says to obtain this graph, shift this graph right 2 units. Wrong. It would go left 2 units. Because remember, it's backwards with your crazy x. Alright, use transformations of the mother function to graph the following function. In a multiple choice situation, guys, you know that that negative 5, this is the square root function, which looks like this. This is going to move it down 5 units. So you're looking 1, 2, 3, 4, 5. You're looking for a graph that looks like this, which is right there. Okay, you don't really... Again, in a multiple choice situation, I mean, we did it where we took the mother pairs. For the square root function was 0, 0, 1, 1, 4, 2, and we would subtract 5 from the y's. That's 0, negative 5, 1, negative 4, 4, negative 3, and if we plotted them, there you go. Alright, so again on this one, we could do the math. I probably should. But again, in a multiple choice situation, save yourself some time. That the negative on the outside is going to reflect over x. The positive 7 is going to move it left 7. So if this was mother, I need to reflect over x, which would make it do this. And then I need to go left 7. 2, 3, 4, 5, 6, 7. So it's going to be over here like that. So it's got to be that one. Again, you could do the math and get the ordered pairs and plot them, but if you're just using transformations and it's multiple choice, okay? Alright, this one is going, the 2 is going to be a vertical stretch. The negative 5 is going to move it right 5, and the negative 1 is going to move it down 1. Again, in a multiple choice situation, let's see if we can figure it out without doing the ordered pairs. Here would be mother. The stretch is a little hard to do just in your head. But I need to go right 5, 1, 2, 3, 4, 5, and down 1. And that stretch is going to make it like stretch, for lack of a better word. Okay? And again, you can't really tell here, but that is starting at negative. It's not starting at 0. If you magnify it, that's at negative, or at 5, negative 1. So that's got to be my graph. Alright, it says begin by graphing the cube root function, then use transformations to do this one. Okay? Well, again, if it is multiple choice, I'm going to do this one like I did the first one. If we did it mathematically, my cubics are -1, -1, 0, 0, 1, 1. Okay, this would say subtract 2 from the x's. That's going to give me -3, -1, -2, 0, -1, 1. Add 3 to all the y's. Nope, sorry. We got two things happening to y. We've got multiply and add. We've got to do PEMDAS order. So I'm going to multiply the y's by a half. And that gives me -3, -1 half, -2, 0, -1, +1 half. And now I'm going to add 3 to the y's. This is going to be -3, this is going to be 2.5, this is going to be -2, 3, it's going to be -1, 3.5. So if I graph those ordered pairs, -3, can't hardly tell, 2.5, -2, 3, -1, 3.5. And there's your s. The other way, again, guys, if you look at this, this is going to go, the +2 means it's going to go left 2. The +3 means it's going to go up 3. And the 1/2 is going to be a vertical shrink, which means it's going to flatten it out. So the only one that went 2 left and up 3, this didn't go 2 left and up 3. This did not go 2 left and up 3. This did. But it was a shrink. This would be a stretch. See how it's like stretched the S? And this made it really flatter, so it's got to be T. Again, in a multiple choice situation, you can find the graph without doing all the math. Alright, and we are done. So, happy studying, and do good on your test.